To cope with the continuous innovation in online services such as data traffic on mobile, peer-to-peer IPTV, as well as audio and video traffic, several new protocols and IP networks were introduced, which made management of those networks ever more difficult. Openflow overcomes these limitations as it redefines the basic concepts of networks and provides a fully open and configurable system, independent of the hardware being used. One of the main concepts of Openflow is the complete programmability of the network. That is, the system administrator is able to choose what traffic to be routed to which link, thus providing a comprehensive management of the information flowing in the network. Openflow is based on a centralized approach in which a single entity called a controller is the main repository and custodian of all information for the network. The controller has a complete view of the network and can thereby make the best decisions, enabling you to implement specific policies for each type of traffic entering the network. Multicast is a type of traffic specification used in multimedia streaming, in which the content of a single server is distributed to thousands of users, such as with films and on-demand TV programs. Multicast optimizes network resources, since each data bit passes only once on each link, and is automatically duplicated by routers in the path, only when necessary. The figure here illustrates that in the case of unicast, the same information is sent individually 3 times, effectively tripling the use of bandwidth in the link above. The demo presented here has been tested on a network composed of 9 Openflow hardware switches managed by an Openflow controller that handles all traffic pertaining to the multicast type. The demonstration of the features offered will be done through a web interface connected to the controller, configured to show the multicast traffic on the network. At time 0, server 1 starts transmitting a media stream using multicast address 224.1.1.1. The controller recognizes and records the flow of information, but since no client has yet to make any request, it sends a command to the switch closest to the server to block data. After a certain period of time, a client on the network sends a join request to the multicast group. The controller, after verifying the information, calculates the best path between the client and server and configures the switches 1, 2, and 3 to forward data to the destination. Subsequently, a second client requires access to the same content. Similarly, the controller searches for the best path between the client and the nearest switch where the content is present. Consequently, it asks the switch 3 to duplicate the data and others to forward it to the destination. After a further period of time, a second server starts sending 2 multimedia streams on the network. One the same as the first server. Instead, the second belongs to the multicast group 224.1.1.2. The controller, not having other clients to serve, sends to switch 8 the command to block the flow of data at the source. Subsequently, the first server encounters a problem and stops the multimedia flow. The controller detects the event, checks if the network has other servers with the same multimedia content, and reconfigures the switch to relay the new flow to the destination, all in less than a second, unlike the 5 or more seconds required in a standard network. We have deliberately used 2 servers that are not synchronized with each other to demonstrate the instant when the flow of data at the destination switches from the first to the second server. A third client then requires access to both multimedia contents, and the controller, after verifying which nodes are closer to the destination with those active flows, respectively configures switches 2 and 3 for the first media stream, while for the second media stream it creates rules on all switches from the server to the client. At the same time, the other 2 clients require access to the second video. As a result, the controller calculates the new locations, configures the 2 central switches to duplicate the information, and the 2 external switches to then forward them to that destination. Finally, Client 2 decides to turn off the display of the 2 films. The controller intercepts 2 requests, sees where to interrupt the flow of video, and reconfigures the switch 3 to forward the content only to client 1. Openflow demonstrates that it is very effective in the management of multicast traffic. The centralized Openflow systems approach allows you to create multicast trees optimized dynamically, modifying it according to the demands of the network, even in the case of failures in the network. Furthermore, through specific changes to the controller, it is possible to obtain ad hoc solutions suitable for different needs, such as dynamically changing the flow paths depending on the load of the network.